2026, question number 1. As is now usually the case, the first question pretty straightforward. Good chance to get some scores on the board. Even though it's only out of 8, still it is nice to get some marks. So state the oxidation numbers of chlorine in each of these species. Cl2, elemental chlorine, 0. HOCl, well, oxygen normally -2, chlorine normally -1. But we know that hydrogen can't be +3, so one of these two has to be something different. Oxygen's more electronegative than hydrogen and chlorine, so oxygen's going to be -2, hydrogen +1, chlorine +1. And then hydrogen, chlorine, well, chlorine's more electronegative, so that's going to be the -1 there. Okay. On its own, this reaction would make the pool too acidic, and so other compounds such as Na2CO3 are added. This removes hydrogen ions. Write the equation for the reaction between sodium carbonate and hypochlorous acid. So let's get started with that. Na2CO3 plus HOCl. Now the temptation here, and my initial thought, and a lot of my students initially saw sodium and chlorine and immediately wrote sodium chloride. But you have to remember here, this acid, the hydrogen is what the acid is going to give us. So this is going to separate into H plus and OCl minus. And if I've got OCl minus, that means the salt I make is going to be NaOCl. And then it's a regular neutralization reaction between a carbonate and an acid, so my other two products are going to be H2O and water. If you write NaCl here you're just going to be stuck all day trying to balance it, and it's not going to work. But if you have NaOCl, it is not a problem to do. So that's going to be a 2. And then I've got 2 OCLs, so I'll put my 2 there, and then I got my 2 hydrogens with my oxygen over here to give me H2O and CO2. No problem. Question part C. Write the ionic equation for the disproportionation of chlorate ions. So we're told chlorate ions, ClO3 minus, it becomes... let's do the disproportionation of OCl minus into ClO3 minus and Cl minus. So let's just go ahead and write those out. So I'm going to have OCl minus becomes ClO3 minus plus Cl minus. And then it's just a case of balancing it. And I mean, there are different ways to balance it. I would just go, well, I've got 3 oxygens here, so I'm going to put a 3 there. And then I've got 3 chlorines. If I change this, that's going to mess with my oxygens, so I just put a 2 there. And then I check the charges. Have I got enough charges? 3 minus here, 1 minus here, 2 minus there. Done, no problem. Okay. Part 2, name the shape of the ClO3. Here you go. Name the shape of the ClO3 minus ion. So you might want to just draw a quick little Lewis structure here. So it's going to be ClO, O, and then you can put your electrons in if you want. And then chlorine, whoops, what have I done there? There we go. And then chlorine has used, well, it's used 2 electrons, 1 each in these bonds, 2 electrons, 1 each in these bonds, and it's used both electrons in these bonds because this oxygen has got 1, 2, 3, 4, 5, 6. Those are the 6 original electrons for oxygen. So that's 1 from chlorine, 2 from chlorine, 3 from chlorine, 4 from chlorine, 5 from chlorine, 6 from chlorine. So I've got 1 extra from chlorine and the negative charge, so I'm going to have a lone pair. All right, now that's my little way of doing a Lewis structure for this kind of situation. You might have a different way of doing a Lewis structure, but doing the Lewis structure is not the... Well, I mean, you can't ask the question really without the Lewis structure, but you need to be able to make sure that you are okay with the Lewis structure. But once you've got it, you can see quite clearly that the answer is trigonal pyramidal. Okay, part D, write an equation for this reaction. Okay, so the third equation so far in the question, very, very nice. So this compound here, urea, undergoes hydrolysis to form ammonia and carbon dioxide. So urea is NH2, 2CO, hydrolysis is H2O, and it's going to form NH3 and CO2. Well, I've got 2 nitrogens here, so I'm going to need 2 ammonias, and then I just double check everything else balances. So 2 nitrogens, carbon, 4 hydrogen, 6. Yep, all looks good. Done. E. Draw a dot and cross diagram. So again, the you know, all fairly straightforward, standard stuff at this level. We've already done arguably a harder Lewis diagram in order to work out the ClO3 minus ion shape, but now we want to do NH2Cl. Well, NH2Cl is going to be N, and it's going to be H2, H, H, Cl, and you know that nitrogen is going to have a lone pair here, and my chlorine is going to have those electrons like that. Okay, no great surprises there. And then trichloroamine, NCl3 is volatile. Henry's law states that the dissolved concentration of a gas is proportional to its partial pressure above the liquid. So the concentration is proportional to the pressure. So C equals Kp. And we're told that the constant of proportionality, I've written here, K, is the Henry's law constant. And for trichloroamine in pool water, that is equal to 435 moles per decimeter cubed atmospheres to the -1. So for a concentration of NCl3 of this much in the water, calculate the equilibrium partial pressure. So then I'm told this number in the question and asked to find this number. Now the only tricky thing in this kind of scenario would be if the units didn't match, but very, very generously this year, and they have really been very kind, I feel, on this question, where they could have messed around a little bit with the units here, is they've given me my concentration in moles per decimeter cubed, and they've given me the constant in moles per decimeter cubed per atmosphere, and they just asked for the atmospheres. So it's really, really straightforward. All you have to do is rewrite the equation as P equals C over K, and then just put the numbers in. I mean, really, all this is testing is can you understand these two sentences? Can you take this relationship and put a constant of proportionality in? And if you can't, sorry, you don't get the final mark in the question. So let's just go ahead and do that. So P is going to be concentration over my constant. So the concentration is 5 times 10 to the minus 4, 5 times 10 to the minus 4, and my K is 435. So I take my calculator out. 5 times 10 to the minus 4 divided by 435 gives me, that's 1.15 times 10 to the 6 times 10 to the minus 6 atmospheres. And we are done. Now I think that might be the quickest Olympiad question that I've ever done. Very, very straightforward to get started. 2026.